I'm Miko Pawlikowski, and this is HockeyStick. Today's topic is MLOps. Like everything AI related at the moment, it's pretty hot. But what is it exactly? How different is it from the humble, old-school DevOps or maybe platform engineering? To answer these questions, I brought in Eric Riddoch, a machine learning platform engineer / tech lead, self-proclaimed MLOps practitioner, and the author of the popular Udemy course, Taking Python to Production, a Professional Boarding Guide. Welcome to this episode, and thank you for flying HockeyStick. Eric, how are you doing today?
Good. Yeah, thanks for having me on. How are you?
I'm great. I can't wait to grill you over this MLOps thing. So, let's just jump right into it. What the hell is MLOps, man?
If that's not the question of the last 5 years. So I'll give a similar answer to DevOps. I used to say MLOps is tools for training models, but I think the DevOps answer always sounded fancier. So MLOps, I would say, is the set of tools and practices for developing data science products and then getting them into production in some fashion, like consumable by users of some sort, and then the operating of those things afterward and then improvement of them.
Got it. So that kind of makes sense, but I'm going to ask you this 3 different ways anyway. But before we go any further with that, so how did you end up doing MLOps?
So I studied applied math at Brigham Young University, which is a cool program. And fun fact, that university happens to be where Travis Oliphant was an adjunct professor when he created NumPy, which is like the math library.
That basically makes you colleagues. You should put it on your CV now.
Yeah, that basically makes us coworkers, contemporaries.
Exactly.
But I think that sets a good context. Like, this math program was oriented towards the math of data science, the data science world. So whereas other math programs might focus on like physics, differential equations to model the real world, this program was more focused on the foundations of gradient descent, the kinds of things you'd learn for models, and then like statistics and that kind of thing. So it was more like a data science oriented program. And so when I came out of that program, I thought I wanted to be a data scientist. That's really what I thought. And I had heard cool talks by people that were like, we predicted the winner of The Bachelorette by just looking at pictures of their faces with a model and rating their hotness. Right. And I was like, that is so cool. That sounds like magic. And then like reality hit, and I was getting towards the end of my program, and I had studied math, and it was like, what do you do after you study math? Probably the answer is you go to graduate school, because I wasn't really a great software engineer, although I did take some classes, and I wasn't like really a data scientist, because that's what the statistics kids had done. Like, they had actually been doing applied modeling and reasoning about data problems, and I hadn't really even seen more than like a simple spreadsheet. So I don't think I was really ready to be a data scientist after coming out of that background. And so I leaned more into the software skills. I was barely able to scrape like an analytics internship due to a friend of a friend when I first came out of school. And so then I like did just like BI analytics using some kind of dashboarding tool, writing SQL queries, and just basic counting of stuff, like how many units are we selling, or how many customers have churned in the last couple weeks. And I think that's actually a really good place to start if you're going to work in any field in data, because it helped me connect back to like, where are the dollars? Like, where does data like actually make money? Right. And so then it was funny, in this internship, I had a chance to train a random forest model, and I was like so excited to fit this like classifier, or I guess it was a regressor, to like some customer churn data that I'd spent like the whole internship writing SQL queries for, just to get like our CRM data and like maybe whether they churned or not. So I did the thing, and I made a little report, like, look how accurate my model is. And then it was just like, no one was interested in it at all. There was just no need for predicting customer churn on this analytics team. And it was just like eye-opening. You know what? It's true what they say. Like, most of the value in data, like, well, maybe for a certain set of problems, isn't actually found in like fancy analytics, which is probably a healthy realization, but also disheartening, because I just came out of math, you know, like, it was cool to train a random forest model. So from there, I was able to switch laterally onto a data engineering team. I viewed it at the time as like my path to data science. Like, this will at least get me some more engineering experience, so that maybe here at this company or somewhere else, I could like switch and finally follow my dream and train models all day. So I did get the chance at that job to work on my first real data science handoff, where this other team had created a feature to predict whether or not a lead was going to buy your product. And so if you're a sales rep and you're trying to decide who to call first, maybe you would trust this ranked list, and you would call the person at the top of the ranked list because of this model, because it gave them like the highest probability of answering, which is really not a very well posed problem in the first place, especially given the data like that we had available in like our CRM. Looking back, it was doomed to fail, this project, but we took 18 months on this model, like sticking it into a REST API in Python and like over engineered. We made like this system where if you thought the model needed to be refreshed, you could hit this API and it would grab the latest CRM data and it would retrain this regression model. And then we had a Chrome extension that was our main product, and you could download this Chrome extension and it would add all these like HTML widgets to your Salesforce page. And so there's a big blue number that we put by all the contacts in the Salesforce page that was the score of 1 to 100. So we built this whole system. It took us 18 months, and we can talk a little bit more about like why it took so long. And ultimately, it totally flopped. It turned out that no one even really wanted it at the end of the 18 months. And if anything, it like probably hurt credibility of the product, like because people would call these names that have this high score, and then like they would get yelled at or something on a cold call. Okay, so that experience, it got me excited because I was like, this one data science project was not useful, but it was actually really fun to harden it and do things to put it into an app. There was a lot of like systems engineering and stuff there. And honestly, it was a lot of just pretty standard software engineering and DevOps work. But I definitely felt like I got to use that math part of my brain. I was like maybe aware of how the model worked. And I was like, so did you guys check what your errors were? Like, how good do you think your model is? Maybe if I didn't come out of a background where I thought I wanted to be a data scientist, I don't know that I would have thought to ask those questions. But I think I had a realization that a lot of people have, and that was, I am struggling to get the job that I want, which is data science. And I was able to get this data engineering job, and I've been able to learn all these software skills. And now I'm realizing that these software things are actually pretty fun, firstly. There's a lot here to learn about. And definitely you can leverage your diverse background. If you like about some data science, that's really helpful. If you know about like engineering, also really good. And also it turned out that was probably the definition of MLOps right there, the MLOps role. And that seems to be a major gap in the industry, or at least it was in like 2018, 2019. Just you couldn't get enough people who knew how to actually put data science products into a customer-facing experience. And so that just meant that like pay was really good. And actually it still is good. MLOps is one of the higher paying niches in the market. And so I was like, you know what? This pays really well. I feel like I have more job security than I've ever had. It's actually really fun. I get to work cross-functionally with data scientists and engineers. Sometimes I get to be either one of those. And I guess it's very exciting to work in a field where you feel like it's like on the frontier and cutting edge, and you're one of the first people ever thinking about this set of problems. Anyway, so that's how I got into it, and then that's like why I stayed. And I don't know, maybe someday I'll want to try being a data scientist for real, but I don't see this as like a path to data science anymore. I see it as like an end in and of itself, and it's really fun. Like it's actually a really exciting field to work. In some ways, we don't deal with a lot of the suckiest parts of data science, like data cleaning. I guess we do a lot of managing expectations, but like from like the data science vertical, I think engineering-minded people, we love to think about abstractions. We like to make reusable tools that could be used to deploy any model. And it's actually addictive to think about those. And the thought of going back to solving vertical use cases is just like way less appealing to me than it used to be.
So when did MLOps actually appear on the map? Because in my mind, this is fairly recent, but maybe I just wasn't paying attention.
I only really started in the workforce like late 2018, honestly. So it's been about 6 years that I've been working. And it felt like when I was scrolling through LinkedIn, it was about 2019 that I first saw people say that word. And it was like the data influencer people who were using it. But I have now met a lot of folks who back in the 2010s and earlier were doing pretty much what I'm doing now. So I guess people have been doing this job for a long time, but it feels like the term didn't really get popular until like almost 2020. Back then, I don't think you would have seen job listings very commonly with MLOps. Mm-hmm. So if that defines the beginning of MLOps, then I think that was sometime around 2018, 2019.
And then obviously 2020, that's where everything that is remotely related to AI is becoming super sexy overnight. So there's that.
That's so true. Yeah,
it's funny. I really like your story. To compare my own, I started as a software engineer, and I've done it. I did it for a few years, and I got super bored because how many APIs can you write and how many best principles you can apply? So then I jump onto like lower level platform. I think today we would call it platform engineering. When my idea was, okay, why just work on one app at a time if I can solve most of these issues for all of the apps in the company and give people like a self-checkout thing. And sounds like you've got very similar kind of path that you do in data. equivalent to that, right? You start with data, and then you end up, I guess, veering towards the engineering part of it, and then you end up doing MLOps. And life is good. And life is amazing.
Wow. I guess maybe there's just something intrinsic about engineers about loving abstraction so much that you want to go solve the biggest problems with reusable tools. That's so funny. It does sound like we had almost the exact same like trajectory of our interests, which is cool.
Man, the egos. It's all about the egos in engineering. That's what it really is about.
That's right. That's right. Yeah, you get to solve the biggest problem, be the most popular.
Yeah, so I guess as we talk about MLOps, we're going to draw a lot of parallel between the cool, new, sexy, trendy MLOps and the old, not so sexy and just regular DevOps and all the other things.
I would love that. I have lots of feelings about that.
As I was preparing for that, I think I saw one of your memes basically with the proverbial wall, and then you got the data scientist on one side and data engineer on the other side. So as a MLOps person, what's the kind of main problems that you're really trying to attack? If you were to plot a pie chart of where you spend your time as an MLOps person, what would be the main things?
Oh, that's interesting. A lot of it is technical and a lot of it is non-technical, and probably everyone would say that. But maybe thinking about the non-technical part first. In like the olden days of 2019, like a data scientist might fill a Jupyter notebook or not with some code to train a model that maybe predicts customer churn or something. And then they would have had maybe like a statistics background or a physics background, but usually almost never a software engineering background. And so, yeah, they were able to follow a data science tutorial to train this model and maybe run inference, but the gap between that and like landing this project like in front of a user is like so large. And so they're older companies, when MLOps was first emerging, weren't really sure what the most efficient distribution of job roles should be. And so they just used the roles they already had. So a lot of companies maybe had a data engineering team, like a team that was like managing databases and ingest of data. And those teams were usually powering non-data science products first, which is maybe how it should go. So basically, maybe you have this established data engineering team that exists already, and now you've just hired in this new data science team, and you got these notebooks coming out of there, and you want to get those in the product. And so that like naturally bred this environment of handoffs where like data science takes notebook, data scientist gives notebook to data engineer, says good luck. Data engineer like tries to turn it into a REST API or something, which is like suffers from all the same problems that all handoffs do when someone just drops something in front of you that you didn't develop and now you own it. So in an early version of MLOps, it was just like, maybe we can like partner with those data engineers and data scientists and help those handoffs go smoothly. Like maybe we can teach the data scientists things that would help them make the handoff better. Like maybe before you hand it to the data engineer, write some docs or take it out of a notebook and turn it into a script. And maybe for the data engineer, it's what is machine learning monitoring? Like there's this big focus on like models get stale over time. And if you were to shop on Amazon.com, like during COVID, you'd get recommended toilet paper and hand sanitizer. And if they didn't retrain their model and then you went and shopped on there today and you were still getting recommended toilet paper and hand sanitizer, you'd be like, what the heck? These are totally irrelevant. And so like to solve that problem, maybe you should track the distribution of outputs of your model and just see, hey, how long has it been since we had 80% toilet paper recommendations? Maybe if that is still happening a month later, we should like refresh this thing. So just some conceptual things, more or less, for the data engineers. And so that has to do with the gap between like R&D and production. And that is a technical and non-technical problem because there's like lots of coaching, but like coaching on these technical concepts. And there may even be like business stakeholders involved that are like, wait a second, why do we need this extra person, this new engineering role to do this? Don't we already have really smart people? Let's see. So then I feel like you said, now I think it's getting more popular to have more of a self-serve kind of thing where it's handoffs are really inefficient. It just sucks to have someone drop something in your lap that you didn't develop. It would be cooler if maybe we could upskill data scientists to a more engineering title. Maybe we could call them machine learning engineers or something. And then maybe you could get the tools and their workflow simple enough and coach them enough that the software development parts of the story and the DevOps part become low enough of a burden that they can actually do everything themselves. They can do the R&D of models and they can put them into production in some form. And that would be great. So you asked what were the challenges of MLOps? What are the problems we take on? So going from development to production is like a big one. In the last month, I feel like I've talked to 5 totally unrelated vendors in like different segments of the MLOps data science lifecycle or whatever. And some of them are literally just tools for transforming data. They're not even like tools for training models, but every single vendor wants to tell you like, we're the vendor that helps you get out of Jupyter notebooks. We help you take Jupyter notebooks to production. And I was like, wow, everyone does that. It's just funny to me because I just don't feel like if you learn a few fundamentals of software engineering, I don't feel like that problem is that hard. And it's just interesting that 6 years later, that still seems to be like a thing that vendors are trying to say is like a differentiator for them, which in today's landscape, I just don't feel like it is. The other part is there is an organizational component. ML products are pretty different from traditional software products. They have a lot of similarities. Like a lot of the time they end up as a batch job that like maybe a data pipeline orchestrator could be running, or they maybe end up as a REST API. So that part of the problem is pretty well understood in software engineering, but this is a thing that deals with data coming in and coming out. And the code could not change at all, but the data coming in could change. Anything revolving around like data quality and making sure that although the code doesn't change, the outputs stay good over time. That's also a pretty hard technical problem.
So. Yeah, I think that kind of explains to me, for example, your course, right? I'm guessing this was extension of your coaching of the other side of the proverbial wall to give them the tools so that they bother you less with the basics, right? Is that the same dynamic as it is between like equivalent software engineers and DevOps in many places where one side thinks, oh, this is just an API, why can't they do it better? And the other side thinks, oh, they're just going to slap some YAML on it to run it in production. What's the big deal? Is that the same in the MLOps
That's great.
world?
I think it is highly similar. Everything you just said, I think would be a problem in data science too. But what makes data science so hard is that I think at least with DevOps and software engineers, everybody's got like a degree in software engineering there. People come in from a lot of backgrounds, but you expect people to have this baseline of software engineering skills necessary for collaboration. Whereas like a lot of data scientists were like PhDs in statistics or something, or they're PhDs in data science and they didn't get those skills. And so there's a similar thing. Like in both cases, you got software engineers, you got DevOps engineers. Maybe there's a handoff, or maybe there's coaching for self-servedness. And like you try to do that with data scientists too, but like not only do you have all the same problems, hey, data scientists, here's how you write YAML, but also data scientists, by the way, could you please use Git? Could you please not commit your 20 gigabyte models to Git so that I can't Git clone your repository anymore on my bad internet connection?
I really feel you there. Back in my day, I was working on a platform for quants. It was like a self-checkout thing in finance where we had all these quants and they could do all these fancy things that I didn't really understand too much about. But you had to train them in the basics of everything to do with computers, and you would get this like random clashes. Oh, wait, why can't I just not load 500 gigs of model into memory? What do you mean it's a problem? It's like that kind of stuff. I'm guessing this is basically the same thing, right? Just a slightly different flavor of it.
Yes. Wow. You're right. I was so arrogant to think that my challenges are unique and no one in the world could understand me. But yeah, what you just said is exactly life every day. But I will say, just in case anyone at my work is watching, where I work right now, it's a very non-dysfunctional team and the data scientists are great.
Oh yeah, don't worry. We'll send them like a letter. We'll be like, oh, he didn't mean it. Don't fire him.
That's right.
All right.
One thing I did want to add too is I think a particular challenge in data science over other flavors of software engineering, and I guess I just called data science software engineering, so maybe that's like a hot take or something, but reproducibility is actually so hard. If you're a data engineer and you write a data pipeline, maybe you want to take a table with some customer data and you want to transform it just so now it's like ready for downstream applications. Like it may not be such a big deal if the version of pandas that you like, I guess, it's controversial. Do you use pandas in data pipelines or not? I don't know. But let's say you're using pandas to do that. Like if you use pandas version 1.2.3 for your data pipeline, chances are there's not going to be such significant changes that if you upgrade your pipeline to 1.2.7, that like you wouldn't expect that change to completely break your data pipeline. But for data science use cases, it actually can be that sensitive. If you change the math of a library even like a little bit, or if it happens to be that the floating point operations that I did on my GPU are different from the ones in production, especially with like big non-quantized neural networks where all the weights are these big numbers, you can start to be sensitive to things like that. And so not only are we asking data scientists to learn some software practices, but also now there's this whole extra thing of we need to track the environment that this model was trained in very precisely. We need to know everything. We need to know like the exact versions of the Python libraries you used, what GPU were you using and what drivers was it, what operating system was it. And I feel like it's very important to be able to get that set of dependencies exactly right in production. Otherwise, it really can break more frequently. And I feel like it's more sensitive there than it is for like more standard software applications.
Thanks for that. So let's talk a little bit about the landscape of what modern MLOps looks like. I am currently looking at one of your slides from one of your presentations that has a lot of logos. A lot of people listening to this are going to be coming from the software engineering background, and obviously they were looking at all the AI-related jobs and thinking, "Oh, I wish I was that sexy." It would be useful if you walked us through everything that modern MLOps pipeline might involve, like all the names, basically name drop all the things and people can look them up later. And I'm going to just sit here and think how different that really is from just a regular platform for anything else that's not ML.
Yeah, totally. And I was going to say, if you want to be sexy, you need to be a data scientist because data scientists are good at modeling, right? I'm just kidding. There's a lot of tools. There's the diagram, like it's by an organization, I think. It's called MAD. Every year they put out like this big diagram of the data engineering space or the MLOps space, and they just fill it with logos of vendors and divide them into different categories. I always show that as a slide to overwhelm people as like a flex. Look how hard my discipline is.
We do the same thing with the CNCF landscape. It's like it started with a few categories and now it's just so big that like if you printed that on A4 paper, you probably won't be able to read any of the names. So
That's amazing.
I see what you mean there. Yeah. Sorry, carry on.
It's important to look smart. Yeah, there's a reason you're paying me so much money. Like, this must be really hard. Let's just only talk about tools, and maybe we can start by talking about categories of tools. So we want to maybe like start by training a model, and then maybe we want to serve that model somehow, and then we could have a story about like how to monitor and update that model. So there's like tools in each of these categories.
Yep.
For training models, you could write a Python script that runs on your laptop, and you could pip install scikit-learn or PyTorch, and you could train something on your laptop. There's this concept of MLOps maturity, and I didn't make this up. It sounds like a businessy term because it is. Basically, like Google Cloud and AWS and Azure, they came up with these like rubrics that talk about MLOps maturity, and they'll like grade you. Like they could come to your organization and see how you do MLOps. They could give you like a 4 out of 5 on your maturity or something. And I think it's a helpful rubric to think about. And so basically you're a 0 in MLOps maturity if you have no automation at all. So like somebody emailed me a spreadsheet of some customer churn data that they exported from Salesforce. I don't know when they did that, and I don't know what they did to export it, but I know that they exported it. So I don't think I could do that again. And don't ask me where it came from later because I'm not going to know. But I do have the spreadsheet. And then maybe I like train a model on my laptop. Maybe I zip up my model together with some code and I email that to somebody else. And then maybe they run it and create some inferences and give it back to the customer. So that'd be like totally manual world. And there's no DevOps practices in there, and there's no automation either. And there's definitely not a lot of like tracking of lineage of where things came from. And then the far end of the spectrum is just like everything is automated. Like you got great tracking, you know what the data sets were for every model, who trained the model, all the dependencies. That was like the reproducibility thing I was just talking about. And maybe you have a monitoring system in place to like automatically detect some sort of performance degradation. Maybe when that happens, it emits an event which automatically retrains a model or multiple. When that happens, there's a part of the process called model selection. You might want to train like 50 different regression models with different settings, basically like hyperparameters. And then at the end, you can just pick which one does best or something. Or if you have compliance issues, you could pick which one does best, constrained by how wild of predictions do we think this might give at the edge cases. Mm-hmm. So that's model selection. So maybe you detected performance degradation, emitted an event, train a bunch of models. You could also maybe automate the selection of, okay, now that I've trained all these models, which of those is going to be the one that I like choose to put into the product? And maybe it's multiple actually. And then trigger a redeployment, and then you're back in the cycle, like back to automated monitoring, back to automated retraining and stuff like that. So the difference of maturity is like everything's manual to everything's automated. And you can actually get really far. In the manual world, you don't need any tools. Like the scenario I just walked you through was like, that could be MLOps in a world of zero automation. And so if you want to start doing more automation, that's where you start like picking up open source tools or buying tools. And so some of the categories are like, so if you've heard of Airflow, I feel like Airflow is the main DAG orchestrator that like is common in the data engineering world. It's like a glorified cron scheduler. If you want to write a script that fetches data every day, you could set it up as a cron job, or you could put it in Airflow, which is like maybe more scalable. And many people do not like Airflow. There's been many reactions to it. It's like the classic, this was the first old tool and had all these rough edges, and now there's like a million different reactions that have spun off. And we at my work are using one called Dagster, and that's like our data engineering DAG orchestrator. And then for data science training, we actually have a dedicated data science DAG tool called Metaflow. And That's actually a really powerful tool. For example, the thing that I said earlier, like reproducibility is really important. Traditional DAG tools still struggle with that, and there's also some other weaknesses that they have. And so it actually makes a lot of sense, we thought, to get a dedicated DAG orchestrator just for data scientists. And so some of the players in that space are like Metaflow, ZenML, Kubeflow is one of them. And there's some more vendors coming out. The ones I just said are all open core.
So Metaflow, that's what the cool kids would use today. That's from Netflix, right?
Yeah. It came out of Netflix. The founder worked at Nokia before the iPhone came out. And so actually, like, back in the early 2000s, got a lot of experience and was thinking about this stuff. Like one of the pioneers of MLOps, and then came to Netflix, and they didn't give him free reign, but he was able to successfully pitch like, hey, let's develop this DAG orchestrator. Did really well. And so they like spun off and created a company out of it called Outer Bounds. Yeah, you're right, though. I do keeping things to open source. Besides maybe like offerings by the cloud providers, like if you're on AWS, you're probably going to hear the word SageMaker. Anyway, so yeah, each of these DAG tools are open core. I would say Metaflow right now is like the most mature, and that's why we picked it. So there's bias because we chose it. So that's like your orchestrator. You can use that to write like cron job like things. And those could be training models, and it could also be like batch serving jobs, like basically anything you could schedule. A batch serving job is when you maybe get some data from a database, run it through a model. Maybe it's like a batch of people that you're going to predict how likely they are to call you back. And so you inference what that is, and then you write those inferences back to some data store, or they can be looked up later. That's actually the core of an ML platform right there. The reason I feel the need to like dwell on orchestrators so much is you can build an entire ML platform just using an orchestrator. Because if you're not serving anything in a REST API, this can be your training tool and your serving tool. And it can even be your monitoring tool, because if you're writing all your inferences somewhere to some sort of data store, you could have yet another batch job that like reads down some inferences. And hey, maybe now that we've actually called that person and we saw they didn't pick up, maybe we can consider that like ground truth. And like maybe we could compare the inferences we made versus what actually happened. And so you could get really far with monitoring just with that too. So the batch world, not making inferences real time by some sort of REST API, an orchestrator can be like all you need. If you're training a lot of models, then that's when you get into experiment tracking land. You want to track all the Python dependencies you used, maybe the Git hash of like your code to keep track of what version of my code did I use when I trained a model. And if you're training a bunch of models, you can also like track their performance too. So if you train 100 models, it'd be nice if you could look up all those things such that when you pick which one you want to put in production, you have this record of all the dependencies and the performance of the model. You need to make that decision. So there's a lot of tools there. The most popular open source one is MLflow. MLflow is just not great. It's like Airflow, and it was like the first one to the scene, really clunky. It got picked up by Databricks, and Databricks has like a closed source distro of MLflow, and it has a lot more capabilities. There's a button you can click in there, and you can set a tag of your model to say whether your model is like production or staging, and that can like automatically trigger a deployment if you like go and select which, like go and take a model and promote it to prod status. But like the open source version doesn't have that, and it's actually just a really limited tool. And so unfortunately, I just don't think there's a good open source alternative to MLflow now. This is a tool that a lot of people do buy, and like Comet and Neptune and Weights and Biases are the big names in the space. There's another one called ClearML, and ClearML is like open core. They're like the Elasticsearch license, and so it's one of those situations where the only people you're ever going to be able to get support from on ClearML is the ClearML company themselves. But what I do like about ClearML is it is self-hostable, and their UI and their like ability to do like triggers and stuff to trigger deployments is actually much closer to the ones that you can't self-host that I just listed. I really wish ClearML would go to Apache 2.0. That would make me feel a lot better about contributing code to them. But as it is, it's pretty generous that they did make their code base source available and self-hostable. I have MLOps friends at certain companies that ran into this experiment tracking conundrum, and they didn't feel like they were good options. They didn't want to buy something, and they are self-hosting ClearML. So that's a good one to look at. Yeah, maybe we can like skip through some of the less used one. So yeah, an experiment tracker is pretty good. Research teams get a lot of mileage out of that because it helps them trace lineage, and then it also helps them communicate what they've tried to both each other and to like the engineers or other stakeholders and stuff. So it can even be a tool that like excited CEOs go and look into to be like, hey, how's our new fine-tuned LLM doing? So it can be like a nice visualization and reporting layer as well. So let's see, the other main ones, maybe we'll just do serving and monitoring and be done. So like with serving, I guess where I work, we had this philosophy that we really want to use open core tools where we can, because we could always self-host if worst came to worst, and they price hiked us like 3x or something since the time we bought it. There's this tool that I've really been liking called BentoML for model serving, and It's really good. The experience feels a lot like writing a REST API when you serve a model with BentoML. And so if you've written a fast API app before and you have little endpoints, like BentoML feels the same. Like you use these little decorators and you put them over a Python function and that becomes like an endpoint. And with a single Python file, which a lot of the model serving tools are this simple as well, but with a single Python file, you can get a REST API. And what's nice about Bento, and this is something that a lot of others try to help you achieve too, is like REST can be slow. Like gRPC is maybe a little faster because you like compress stuff before you send it over the wire. And I've heard people say that the speed of their product is that they use gRPC instead of REST, which there could totally be stuff to that. And also, maybe a REST API isn't where you always want to be serving your models. What if you need to run inference on a massive data set that's too big to fit in memory? Then like maybe you're in Spark land. And so if you have a PyTorch model, you might want to run inference with PyTorch, but Spark is written in Scala. There is PySpark, but it turns out that you can turn Python functions into a Spark user-defined function. And for example, if you have a model with PyTorch, you can turn it into a Spark UDF, and then you can deploy that to like go run inference on mass, like on really large data sets. So if you have like massive batch problems, you can use that. And so where I'm going with this is depending on your serving use case, like depending on your data, like how frequently you need to make requests, can you handle batches or not? How big of the data? There's different serving tools that can accommodate all of those. And BentoML, what we liked about it is you can write one little Python script that can then actually, with no code changes, be a REST API. Or with a config change, you can change it into a gRPC API. Or you can actually run a little packaging builder command that they have, and then it just becomes a Spark UDF. You can put it into Spark. And so one of the big struggles with platform teams always is that you're trying to anticipate use cases of other engineering teams in the future, because the second you need to do inference on massive scale data, you don't want your team to be like, oh, that's really complicated and it's going to take us 3 months before we can do that. You want to have an answer for them like pretty soon, even if it's a scrappy like workaround answer. And so I think optimizing for flexibility is really good. We chose BentoML because of the flexibility. I don't know. We've used it and I actually think it's really good. Maybe you could make an argument that because it's flexible, maybe it's not the best in any one category, but I actually think the velocity that a tool like that gives you, it makes it worth it. So alternatives to BentoML, just to name them, SageMaker endpoints is where a lot of people start serving their models. One issue with SageMaker is that it's on AWS and you're locked into AWS. I think lock-in is totally fine, but in a world where there's not a lot of GPUs going around, you can actually hit a GPU quota ceiling in AWS really fast. It's really scary every time you need to ask AWS for more GPUs and you don't know if they're going to give them to you or not. If you're like in flight and you have a product that's just taking off and it needs to autoscale and you can't get access to GPUs, that's really scary. What a lot of vendors are offering, like Metaflow does this, for example, you could self-host Metaflow yourself, this DAG tool, and you could run it in your own AWS account. But at some point, you're probably going to run into GPU quota limitations. But if you partner with a vendor, and Outer Bounds isn't the only company that does this, and I think this is really great, the vendors can help you deploy onto multiple clouds to get access to like multiple pools of GPUs. And there's some companies like CoreWeave, which basically all they do is have data centers filled with these GPU machines that you can get access to. And so one nice thing about working with vendors is they can leverage these partnerships to help you be able to autoscale on that hardware without you actually having to worry about the details, which is pretty cool. So that's your serving environment. And then last one is maybe like monitoring. There's not really a good open source monitoring tool right now. So some of the closed source ones are like YLabs and Aporia and Arise AI. I think those would be the most common if you just did a Google search right now. And there's one open source library coming out called Evidently AI. I think they're worth watching because I think the world is hoping that this will become like the best self-hostable offering. But yeah, basically what those tools have you do is if you have a REST API or if you have a batch job, you send information about incoming data points to their platform, and then you send information about the inferences you make to that platform. And those platforms either store all that data on their backend or in your account, or they store like summaries of that data. And basically they give you a layer to catch like drift in features and stuff. So if your model is having performance degradation and it turns out that, hey, when the ground truths come in, the accuracy turns out to be really off compared to the inference, then they can like issue an alert. And then you can react to that event, maybe with your orchestrator system or something like that. One thing I'll say about monitoring, though, it's like the last thing that a lot of people set up. And it's actually pretty okay that's the case, because a lot of data science projects start as like these early POCs and they haven't even proven value yet. And monitoring is pretty complex to set up. And so I actually personally believe that it's okay to skip that step when you're in the early phases of experimentation. And one thing that's interesting about ML monitoring is what's the risk and what's the remediation? If you get a fancy monitoring tool, what are you expecting it to do? Like in classical ML world, where you're talking about just like regression and classification, you're asking it to tell you when your model's drifted or like when your performance is bad. That's pretty much it. And the answer to that question is usually retrain your model on some new data. And so if you have new incoming data coming frequently, you could just retrain your model every day and then it would never drift. And so you wouldn't need a monitoring tool. I feel like the market for the ML monitoring vendors is more for like when retraining is like too cost prohibitive for you. Like if for whatever reason you're working on so much data that the retraining is like totally infeasible, or maybe data is really expensive. Maybe you're in this world where you actually need to have a warehouse of like underpaid people labeling boxes, annotating images, identifying where the cats are or something. Like if you need to have like assistance with data annotation, or if data is expensive to get, then you don't have an incoming stream of data. So then it could be great to use one of those tools, because one of those tools could maybe say, oh, hey, we're out of performance, that we're not predicting cats versus dogs very well, so let's deploy a fleet of humans to go label us some more images. But then again, if you're in that world, I think for a long time, you can still do like an ad hoc analysis and make that decision yourself. Maybe you write a script that like compares inferences to errors. So yeah, that's pretty much the stack. We got our orchestrator for training and batch serving, and also integrates hopefully with like cloud providers such that you don't run out of GPUs. And then an experiment tracker to trace lineage. And I just don't think there's great open source options there. And by the way, the closed source options are so expensive. Like for what I consider a really basic contract at one of these SaaS companies, they were asking us like $200K a year to just like track the Git URL to a repo for a model experiment or like those performance metrics. And I was just like, that's just so much money. Anyway, so I think self-hostable options in that space would be really good. And then there's serving. So whether it's a REST API or a Spark UDF or a batch job, but if it's a batch job, you're back in the orchestrator world. And there's a lot of the popular tools there, like BentoML, Celdon, SageMaker endpoints. Google Cloud and Azure both have offerings for that too. Those are probably the main ones. There's this up and coming new runtime called the Triton Inference Server. And this is basically an SDK that allows you to really get the most out of your NVIDIA GPUs, but it has a rough user experience. So I would still use BentoML if I wanted to serve on that. And then there's the monitoring tools. And right now, especially with monitoring, there's not really great self-hostable open source tools. But the point I hope to drive home is you can get really far either not setting one of those up or rolling your own in a very basic way. And then later on, you could get a more expensive one.
What about PyTorch? Are cool kids still using PyTorch? What happened to TensorFlow? What's the behind the scenes?
Cool kids are still using PyTorch for sure. Maybe this started with Ben Taylor, but I feel like there was a streak on LinkedIn for a while of influencers who would just rail on TensorFlow. And they were like, I don't know, were you even a real MLOps team if you had TensorFlow anywhere in your stack kind of thing? And TensorFlow actually has its own whole like MLOps suite. There's a thing called TF serving for serving TensorFlow models specifically in a high performance way. And I think a lot of big companies like Etsy are using that today. And that's really good. And I know, I think they may even have their own orchestrator and like the TensorFlow version of all of these things that I just said. By the way, all the things I just said could also use TensorFlow. What is difficult to me about TensorFlow is I think PyTorch is more Pythonic, and it seems to have captured the imagination of the research world, which means like more and more like of the fancy cutting edge models that come out, like when you go to get example code to run them yourself, that code is using PyTorch. But a really big complaint people had with TensorFlow is it was really hard to install. It's weird that this is such a sticking point, but it was such a sticking point. Like it made adoption so hard for both practitioners and like ops people who are trying to deploy things. So like in Python, there's this packaging format called a wheel. So Python is like this really slow language. Like for loops are like a notorious weakness in Python, where if you have a performance issue in your Python program, you should check in to see if you have a for loop, because for loops are like really costly in Python. So it is a little weird. Like, wait, why are all these like really compute intensive data science libraries written in Python? Isn't Python too slow for that? And then the answer is Python is this orchestration layer on top of binaries that were written in more performant languages like C++ and Rust and Golang and stuff like that. And so when you're using a machine learning library in Python, behind the scenes, you're really making calls to these lower level compiled languages. But the thing about compiled languages is that they need to be compiled for a specific target hardware. I'm on a MacBook Pro right now with an M2 chip, which means my Mac is like ARM. And so if you gave me a compiled version of C+ TensorFlow, it might not work on my laptop at all, because maybe the one you gave me was for like an x86 processor. So as processors have come out, they've become more savvy to like advancements in machine learning. So at the low hardware level, some newer CPUs actually have instruction sets built into them that are much more optimized for like matrix multiplication. And so if you're running an older CPU that doesn't have these optimizations and you run TensorFlow, then I could run the same code on a different CPU that does have these optimizations, and we would see like wildly differing results between the two of us. So I guess one of the big problems is when you package a Python package that's going to have these like lower level binaries that come with it, those binaries need to be precompiled. And when they're precompiled, they need to be precompiled for like a certain target hardware. And they only vend officially one wheel that you can download. And that wheel is compiled for the lowest common denominator of all hardwares, just so that like they can ship one once and they can trust that anyone in the community will be able to use it, which means that you get the suckiest version of TensorFlow every time. When they compile TensorFlow, you get a version of it that isn't built to use these hardware accelerations. And so it'll go slow. And so very often it's the case that you actually have to compile TensorFlow from scratch yourself into a wheel, like with your target hardware in mind. And that's really hard. And I once paid a friend $75 to teach me how to compile TensorFlow because I was trying to get it working for my job. And on my Mac with 32 gigabytes of RAM, I tried to ram this Docker container and I ran out of memory. And so then I downed the memory a little bit and then it just took like forever to run. And by the end of that, we had a compiled TensorFlow binary. And then I was like, what do I do with this? Do I host this myself? Do I put this in Google Drive? Or do I upload this to like TensorFlow-Eric, like on PyPy? Like I wasn't even sure. And now I guess I have to maintain this now. Anyway, so that's just one of many examples of like how TensorFlow was difficult to adopt. And there were enough rough edges there that I feel like at some point people just got frustrated and left. So anyway, that's the story.
I did wonder whether there was more to it in terms of like corporate politics, because Google behind TensorFlow, and then you had Meta that had vested interest in Google not taking over the machine learning world and investing in PyTorch. So I wonder if there was also that.
Yeah, that probably would have been a more interesting kind of response for a podcast. And you know what? I bet there's definitely some of this at play, and I just don't know. So yeah, I gave like a very engineering focused answer. Like it's just hard to use, but there is more. Like politically. So
I'm sure it played a big role. So how does PyTorch achieve that? Do they just offload it to CUDA and that's why people have better experience? Why does PyTorch not suffer from the same issue as the one you just described?
In TensorFlow's defense, they can both use CUDA, and then TensorFlow can also use like TPUs, which are like Google's proprietary accelerated chip, which doesn't do PyTorch developers much good. I don't know if you can run a PyTorch model on a TPU. No, you can, because Google wants you to be able to do your cloud spend with them, no matter the framework you're using. But let's see. So why does PyTorch not suffer from the same issues? For one, they just vend more versions of their wheels. If you're installing a wheel, chances are you can get one for the hardware that you're working with. Yeah, I feel like that's the main answer. Also, PyTorch, I feel like is a more natural abstraction for Python developers. There's probably a lot to unpack there, but if we're going to make the DevX argument, I think most people would say that the DevX of PyTorch is superior.
I guess my last question now to wrap up the MLOps part of it is, what would you say are the main pain points now and what needs solving about the MLOps person's daily life? What sucks the most?
I think it depends where your company's at. For example, like 2 years ago-ish, I was the only person with the MLOps job title. And I was doing a lot of DevOps kind of work. Like we were setting up networking with VPCs in the cloud because like it turned out that getting access to the models that we deployed in our services was really hard. And so that became like this big focus for a long time. And we hired a new high-level leader at the company who had been like really successful at a software engineering company, but it was a software engineering company. Like with a traditional SaaS product, they didn't have a lot of advanced AI features there. And even 2 years ago, I was a lot less confident than I am now about like how to do MLOps or what the actual needs are. And so I found myself like really struggling to explain to this new leader why my role was important. Or for example, he really wanted me to be embedded into the DevOps team, which would have put a lot of distance between me and the data scientists and me and the data engineers. But I think in his mind, that made a lot of sense because the work I was doing at the time was like networking and like auto scaling and making deployments easy. And he was like, we have needs for that all around the company. And I was like really nervous about this because if you're in MLOps, that means you're not in data engineering and you're not in data science, like most often. But you really need to know about what data is available and like how available it is. And if you're not like actively working closely with those groups, you're just not going to know like the amount of knowledge that you need to do your job. Yeah. You're not going to have that. And same with data science. If you don't have a really good pulse on what's upcoming, then you're not going to be able to like do the thing as a platform engineer where you're like anticipating their needs and making sure they're not blocked when they come up. And so I just found that like there was a general lack of understanding and leadership as like about what data science needs are when it comes to putting things into production. And that put a lot of stress on me to defend the entire discipline, the entire field, and also justify like why I'd be embedded in this certain place. And I should also say the reason I joined the company I'm at is because some of our leaders are like really savvy with this. This is a fantastic company with fantastic leaders. But if I weren't in a company of such a positive culture, that actually could have washed me out of the field. It could have turned me into a pure DevOps engineer, and that would have been that. From an engineering standpoint, but also from just the standpoint of, can we be a non-dysfunctional AI company? I just think it's so important that leaders more and more understand the non-sexy stuff. Like, truly, what is the DevOps component of MLOps? What is the software engineering component of MLOps? And why can you not just take a DevOps engineer and put them into an MLOps role and expect things to go well, for example? What is the set of skills and experience that you do need to know in order to specialize in this? I hear a lot of people ask, like, how can I justify myself or my existence in my company as an MLOps engineer? And I'm just like, man, I don't have an answer for you. But I know that if your leaders were open, then probably that's where you should start, is education there. So that's like challenge one. Challenge two, with tooling, like everything, there's a lot of sprawl. And so it seems like other forms of platform engineering, MLOps engineers are like glue engineers. And you can self-host stuff. It's great if you're a competent cloud engineer and you can grab some things and self-host them. But even once you stand something up, like maybe you stand up an orchestrator or a serving tool or an experiment tracker, then you have to get them to all talk to each other. And you have to design like workflows so that everyone's doing things in a roughly standard way. And that is really hard. And I think all the vendors know that's hard. And so all the vendors now, I hear them talking more and more about, we have so many integrations. We make it so easy to work with BentoML if you're using our serving tool, for example. And I feel like the industry still needs so much help there. And I feel like a lot of people would hear that and say, why don't you just use an all-in-one platform? SageMaker has an answer for everything: training, serving, monitoring, or so does Databricks. And Databricks, they should market their tools, and they definitely market their tools. And same with Google Cloud, same with Azure. So why don't you just use one of the all-in-one platforms? The all-in-one platforms, they just lag behind. They tend to be pretty decent for the happy path of the simple first 60% of your data science use cases. But the second you want to try out the latest fine-tuning strategy with an LLM and then apply like LLM-based monitoring, they're not built for that. Let's take LLM monitoring, for example. Like, how do you stop LLMs from like hallucinating? How do you stop LLMs from like putting out offensive content? Or like image generation too, that's really hard. That's a really hard problem, and the big all-in-one platforms are not the people leading that discussion. It's usually like the smaller, more specialized vendors that are doing that. And so if you're on the cutting edge, you almost have no choice but to go work with partners who specialize in that thing. And so to get an all-in-one platform, I think, is, for companies on the cutting edge, a bad idea. But for companies who just have very basic data science needs, sounds great. Take advantage of having all those integrations just done for you. Because you can save money, technically, if you get an all-in-one one, because you have less engineering effort, upfront at least, and you get all these tools rolled into one package. This is something that managers will always push you on. Like, why don't we just go get Databricks? Or why don't we just set up on SageMaker? And the answer is, maybe you can, and that makes it really hard because you have to be really confident that the use cases coming up for you are going to outgrow that. And that's hard to know in advance. But I've found that in today's landscape, especially if you're working at like a software company, and especially if the core of your product is AI, then it may be more obvious to you. So yeah, navigating the build buy and all-in-one versus not all-in-one, and then pitching that's pretty hard. And integrations are a big part of that. One thing I do want to say is just data scientists and the skill level that they're often at, and same with engineers and their backgrounds. Like, there is coaching and training that both of those groups need and are very capable of, by the way, of attaining in order to do AI non-dysfunctionally. So for data scientists, it's often just like the software engineering basics. Hey, if you could just have a reasonable commit strategy, and if you could like semantically version these functions that you're giving to me that I can consume and help you deploy, that would be great. You can get a lot of mileage out of that right there. Also, just like data scientists often don't know about automated testing. There's lots of cases where like just knowing how to write unit tests can add like a whole new level of rigor to a data science product. So from there, we often in this field deal with data scientists who just aren't willing. They were maybe the top PhD in their program or whatever that means. And I've never needed Git before now. Why should I learn it now? And it is amazing how much that can slow you down. Like when you have people who are just like unwilling to learn. And I think in the companies I've worked for, they've been totally willing to learn, which is great. I've definitely encountered personalities that were harder to get along with. That makes it really tough. So once you're willing to learn, like, what are the resources? That was why I made the course. I literally made it for my coworkers. Then I was just like, okay, I'll put this on Udemy as well. And it was just like, here are the 5 commands you need to know in Git. And by the way, It gets really hard. So here's how you use the visual viewer in VS Code, and here's how you write tests and stuff, and here's semantic versioning. So it's like really basic stuff. And I can say that it has been like a night and day difference after working with some people who, like, if not my course, like maybe treated it as a syllabus and like just went off and used free resources to get it. So training is important there. And then similarly for software engineering, I think Matthew Sharp had a post on this on LinkedIn. He was like, one of the worst parts about MLOps is software engineers who think they can just train a model and put it in a product and things will go well. And I think what he was complaining about there is they don't track anything. There's no sorts of lineage. Hey, where'd you even get this model? Or what data did you use? Were you allowed to use this data? Are we like violating some sort of compliance right now because you did this? There's definitely some like experiment tracking stuff, just general MLOpsy things that I think a software engineer needs to know. If you can get two groups of people that are like willing to upskill in the right ways, it's just a really fun working environment and you can go really fast. And if you don't do that, you could probably still succeed, honestly, but it may not be as fun because you might argue more and there might be more egos, or you might spend 3 weeks before a very important YouTube conference where you're going to be trying to demo this thing that generates YouTube thumbnails, and you spend 3 weeks leading up to that literally just seeing if you can get it to run on somebody's laptop that they can take to the conference because no one documented their dependencies, like what happened to us a year and a half ago. So yeah, leadership, knowing stuff, upskilling on both sides, and integrations between the tools. It's just really hard to get them to talk to each other.
Awesome. Eric, important question. Imagine you can talk to a 5-year-old version of yourself, and that version of yourself is considering either being an astronaut, an actor, or an MLOps person. Which one would you recommend to them? And why MLOps?
That's awesome. The 5-year-old Eric really wants to do MLOps. I'm just kidding. For me, it's like a probability thing, like risk versus reward. Like trying to be an astronaut sounds pretty high risk to me. So I'd be like, if you're thinking of being an astronaut, just consider that there are many career paths which might lead to an easier way to provide for a family. So I don't know. I do think to myself, like, why do I love MLOps? Because I really do love MLOps, and I like unironically like use LinkedIn as like my main social media, because that's where those people are at. And I'm like, did this have to happen? Was this destined that I was going to be an MLOps engineer? And honestly, I think the answer is no. And I think this is true for a lot of people. If you can find something that you can be an expert at, or you can be like a high percentile of performance in that field. Since MLOps is new, I can make statements like, yeah, I've done MLOps almost as long as everybody, because it literally has only been a thing for 6 years. So if you can find a field where you can feel like you're one of the leaders in it, or like you have a lot to contribute, that's really motivating. It's also motivating to feel financially stable, like I'm going to have like work opportunities in the next several years. When those two things combine, I feel like passion can be generated. I think if there were another discipline that had those same two properties, like I can be good at this and this will take care of me. And especially the more passionate and the better at this I become, it really does look like there are better compensation opportunities for me. That right there, I think, is motivating for a lot of people, just to not have that financial stress. And it also is like very interesting work too. So yeah, I don't know if being an astronaut has that, but I doubt that like major innovations have happened in accounting in the last 20 years. I don't know, maybe AI will change the way accounting is done. But data engineering was a new field, and there's a lot of people who like rode that wave. And honestly, there's probably still opportunity there to do that and be really passionate about it and have a big impact. Outside of software engineering, I don't know. I assume that like lots of different R&D type of things exist. As far as like choosing a career path, I don't know that I would say follow your passion, but I would say maybe try to develop a passion around your strengths, and then you can be really fulfilled.
Sound advice. All right, man. Eric Riddoch, everybody. Thank you so much for coming.
Thanks for having me on.